Hey guys, sorry I wasn't able to be with you yesterday and again today, but I know Miss Puckett did a fantastic job getting you started on simplifying square roots or radicals. I want to make sure that you know that you need to memorize these perfect square numbers 4, 9, 16, all the way up to 144. For a test grade, I will call you up to my desk one at a time on this coming Monday, and you need to, within 30 seconds, be able to recite these numbers 4, 9, 16, all the way up to 144. It's really important that you know these numbers in order to simplify radicals. So they're called perfect squares because they are the numbers squared, meaning they have been multiplied by themselves. So 9 squared, 9 times 9 is 81. That's called a perfect square because it's gotten by squaring a number. When you are simplifying radicals, it's similar to simplifying fractions. You want to get it down to its simplest form. So, for example, 18 over 36 is not a simplified fraction. Now, I know they're both even numbers, so I know I can divide them by 2, but when I do that, I am not fully simplified yet. Even though this is more simplified than this, it is not fully simplified. So we would divide the numerator and denominator both by 9 and get down to 1/2. This is the simplified version of 18 over 36. They have the same worth, they're equivalent to each other, but this is the simplified version. So that's what we're doing with a radical, is trying to get it down into the most simplified version. We can only take square roots of perfect squares. So for example, I can take the square root of 81. It is simply 9. You also should have learned yesterday that all even exponents are perfect squares. So you should have learned that you can take the square root of x to the 6th, because that's an even exponent. You just take half of it. So the square root of x to the 6th is x to the 3rd. And the reason is the same reason why the square root of 81 is 9, and that's because 9 times 9 is 81. Same thing here. X to the 3rd times x to the 3rd is, remember you add those exponents, x to the 6th. So all even exponents are perfect squares. Not all even numbers are, but all even exponents are. So when you are given a radical, you want to get it into its most simple form. So with the number, you're going to look and see if it's a perfect square, as it is. Well, 20 is not one of our perfect squares. And so I want to break down 20 into two numbers that multiply to get 20, but one of them needs to be one of these perfect square numbers. If you don't know what numbers multiply to get 20, you can use your graphing calculator to help you. If you go to your y equals on your calculator, you can type that number, which is 20, and do divided by x. It's always important to do divided by x, and look in your table. Here are numbers that multiply to get 20. 1 times 20 is not helpful. Even though 1's a perfect square, it still is going to leave you a 20 under the radical, so you haven't accomplished anything. 2 times 10 is 20, but neither 2 or 10 is a perfect square, so that's not helpful. This is a fraction, so then we have 4 times 5. 4 times 5 is great because 4 is a perfect square. So I'm going to break down underneath the radical the 20 into 4 times 5. And the reason why I did that is because 4 is a perfect square, and so I can take the square root of it. With the variables, you want the exponents to be even. Only even exponents are perfect squares. So x to the 5th is not a perfect square, but I can break down x to the 5th into that variable with an even exponent right below 5, which is 4. X to the 5th is the same thing as x to the 4th times x to the 1st power. If you add those exponents, you get x to the 5th. So I'm going to separate the x to the 5th into x to the 4th times x to the 1st, because the x to the 4th is the perfect square. Same thing with the y to the 3rd. The even number right below 3 is 2. So I'm going to separate y to the 3rd into y to the 2nd times y to the 1st, because y to the 2nd power is an even exponent, so it's a perfect square. I always circle my perfect squares so I can see what numbers I need to take the square root of and bring them outside the radical. So I'm going to take the square root of 4. The square root of 4 is 2. When I do that, that 2 comes outside the radical, but I'm going to start a new line because this becomes my answer. The 5 is not a perfect square. The x to the 4th is. All even exponents are perfect squares. Just take half of that exponent. So half of the 4 gives me an x to the second outside the radical. And then the y to the second, since it's an even exponent, just take half of it. That becomes y to the first. And remember, you don't have to do an exponent of 1. You can just leave that as y. Now, everything that I didn't circle is still stuck underneath the radical. So under the radical, I have a 5, an x, and a y. This is my simplified answer. I took the square roots of everything that I could, and everything that's left underneath can't be taken the square root of. It's not a perfect square. So let's look at another one here. The number is 24. So remember, you can go to your y equals if you don't know these numbers. Put in 24 divided by x and look in your table. So again, 1 times something's not going to help. 2 and 12, neither one are a perfect square. 3 and 8 are not perfect squares. 4 times 6 is helpful because 4 is a perfect square. So I'm going to separate the 24 into 4 times 6. I'm going to circle the 4 because it's a perfect square. The x to the 4th already has an even exponent, so it is already a perfect square. The y to the 7th, 7 is odd, so I'm going to rewrite that as y to the 6th because that's the even number right below 7, but don't forget your y to the first power so that it's still equivalent to a y to the 7th. Y to the 6th times y to the 1st is the same thing as y to the 7th. Same thing with the z to the 13th, since that's odd, I'm going to rewrite that as z to the 12th times z to the 1st. The even exponents are the ones that are the perfect squares. So I'm going to take the square root of everything that's circled, and don't forget to change it when you take the square root of that number. The square root of 4 doesn't come out as a 4. The square root of 4 is 2, so it comes out as a 2. Even exponents just take half of, so the square root of x to the 4th is an x to the 2nd. Square root of y to the 6th is a y to the 3rd, take half of that. And the square root of z to the 12th is z to the 6th power, take half of that. Everything that's left under the radical that's not circled stays underneath the radical. And remember, you don't have to use those exponents of a 1. You can just write it as y and z. So this is my simplified version. One common mistake I see is students bringing these out is exactly the same thing. So bringing that out as an x to the 4th would be wrong. The square root of x to the 4th is not x to the 4th. It's x to the 2nd, because x to the 2nd times itself, x to the 2nd is x to the 4th. So make sure you're changing those when you bring it out. Remember, even numbers are not perfect squares. Even exponents are. So don't get those two rules confused. All right, let's look at your next example. The only thing different on these two is you already have something outside the radical. So all that means is that when you bring your square roots out, they're going to have to multiply by what's already out there. Don't add. This is not addition. When you have a number beside a radical, that's always multiplication. So whatever comes out is multiplied by what's already out there. So 60 is not a perfect square. It's not in part of our list of perfect squares. So again, I would suggest, if you don't know the number, to go to y equals and put 60 divided by x. Look in your table, and remember, don't start with 1 because that's not helpful. 2 and 30 are not a perfect square. 3 and 20 are not perfect squares. 4 and 15, that works because 4 is a perfect square. So I'm going to separate the 60 into 4 times 15. Make sure you remember that 7. It's still part of it. All we're doing is replacing with something that's equivalent. Odd exponents are not perfect squares, so I'm going to rewrite x to the 3rd as x to the 2nd times x to the 1st. Don't forget, that's still equivalent to x to the 3rd. Odd exponent, write it as the one that's even right below, and don't forget the y to the 1st. That is still a y to the 7th. Circle your perfect squares. 4 and my even exponents. So that's what I'm taking the square root of. The square root of 4 is 2, but there's already a 7 out there. So when that 2 comes out, it has to multiply by the 7 to become a 14 now outside the radical. So remember, don't bring that out as a 4 and do 4 times 7. That would be incorrect. Take the square root of 4 when you bring it out, which is a 2. 2 times 7 is 14. The square root of x to the 2nd, just take half of that exponent, is an x to the 1st. So I'm just going to write it beside the 14 because that's multiplication. And remember, I don't need the exponent of 1. The square root of y to the 6th, just take half of that 6, is a y to the 3rd. Everything that's not circled stays under the radical, 15xy. You will never have a variable with a higher exponent than 1 and it be simplified. That's the most it will be left in there as a variable to the first power. Okay, so let's look at one more. Underneath the radical, 12 is not a perfect square. So hopefully that's one you know, but if it's not, if you put 12 divided by x and look in your table, you'll see 1 and 12, never helpful. 2 and 6 are not perfect squares. 3 and 4, that works because 4 is a perfect square. So I'm going to bring down the negative 3x to the 2nd outside, but I'm going to rewrite the 12 as 3 times 4 because 4 is a perfect square. The exponents must be even, so I'm going to rewrite that 5 as x to the 4th, but don't forget the x to the first power. That still becomes x to the 5th when you multiply that together and add your exponents. I don't have to break up the y to the 8th because that's already an even exponent as it is. So I'm going to keep it y to the 8th. Circle the variables with the even exponents because those are your perfect squares. Everything that we take the square root of, remember it changes when it comes out and has to multiply by what is already out there. So when I take the square root of 4, it is 2, but it's going to multiply by the number out in front, which is a negative 3. So 2 times negative 3 gives me a negative 6. The x to the 4th, when we take the square root of it, we take half of that exponent, so that's an x to the 2nd. We already have an x to the 2nd out there. So remember, you're going to add those exponents, and that's going to give me an x to the 4th outside. And then the y to the 8th, the square root, you just take half of that exponent, and that's a y to the 4th. There wasn't a y to add exponents with, so it just stays y to the 4th. What is not circled stays under the radical. The 3 and the x stay inside. So the square root of 4 came out as a 2, but it multiplied by that negative 3 to give me that negative 6. The square root of x to the 4th is x to the 2nd. It multiplied by the x to the 2nd that's already there, and you add those exponents. And the square root of y to the 8th is just y to the 4th. The 3 and the x stay inside. So now you can work on the assignment from yesterday's lesson, and hopefully I'll see you tomorrow.